Hi. These are the 6 formulas that we need to know for linear motion, chapter 2.4 physics. Right. The first one should be the basic formula. Uh, V equals to U plus AT. Actually, we got this formula from the first one. A equals to V minus U per T. So this formula will become AT equals to V minus U. So AT plus U becomes V. All right. Okay. So the formulas are A, B, C, and D. And then, so these are the 4 common formulas. Actually, these 2 formulas we derive from A and B. I'll show you in a while how we get that. And then the next 2 formulas are average speed and average velocity. So average speed will be total distance per total time. Average velocity should be total displacement per total time. Okay. We'll be using all these 4 formulas, 6 formulas, all right, to solve linear motion, any type of movement. The differences between these formulas, if you observe properly, will be, all right, in the first formula, I call it VATU, there's no S, displacement or distance. The second formula, I call TDU as, there's no A, acceleration. In the third formula, I call SATU as ATU. You see there's no V, final velocity. And in the last formula, you see carefully, as AVU, there's no T, time. So these are the common 4 formulas, and adding the other 2 formulas, average speed and average velocity, right? Okay. Okay, if you look at it, guys, what happened here is that we have 4 formulas to remember. The first formula is A equal to V minus U per T, where we can rewrite as T equals to V minus U per A or V equal to AT plus U. Same formula, we manipulate. Okay, how do we obtain this formula? When we sketch a graph of velocity against time. So when you have a graph of velocity against time, the gradient of the graph is actually acceleration. Remember that. When you have a graph of velocity against time, the gradient represents acceleration. The gradient is here, is the acceleration. And then the area under this graph, is actually the displacement or distance. All right. So we got 2 formulas already. So what is the gradient? V minus U per T or T minus 0, we got already. Okay. And then what's the area? It's you can see here, you can calculate already. Okay, trapezium. So you got your area already. Okay, next. What happened next? We got 2 other formulas to identify. If you see the notes there, these are the 2 formulas. How do we get these 2 formulas? We derive from the first 2 formulas. So we take formula 2, all right, inside formula 2, we substitute the T here from formula 1. So substitute T from formula 1 inside formula 2, we get V minus U per A. We replace the substitute the T with this. So as we work it out, 2AS equals to U plus V minus V plus U, or V plus U equals to times V minus U. Okay. So we continue from here. We realize that we rearrange V plus U, all right, and V minus U. So what we get here, we get 2AS equals to V square minus U square. So we were able to get this formula. That is V square equals to U square plus. So I'm telling you how we get the formula. It's in the syllabus. So practice, guys, copy properly. And then here, what we do here is that we try to understand, okay, how do we get the last formula? So this formula we rearrange, we bring the 2 up. So we get 2S equals to U plus VT. We substitute the V, which we get from here, from the first formula, and we work it out. We finally get this formula. So this is how we get the formulas, right? So once we solve this part already, all starts from this graph. Okay, so we have to know how to use these 4 formulas. And also, of course, the other 2 formulas, which is average speed and average velocity. This is the ticker tape, right? This is the tape. And this tape was moved under the ticker timer. So as I said earlier, the time in between these two dots are called interval. So how many interval do we have here? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. The 10 intervals are called as the 10 dots. So how do we calculate the velocity then? Velocity of this stick, which was moved by a trolley, for instance, will be the displacement over time. So the total displacement found to be from the first to the last dot is 20 centimeter, and the time taken, 1, 2, 3, here 10 dots, right? Or 10 interval, 10, but you have to times with 0.02 seconds. Why? Because each interval from here to here is 0.02 second, here to here also 0.02 second. So you end up getting 20 centimeter over 0.2 seconds. So you will get 10 cut here, 100 centimeter per second. So move this back, move here, you get 100 centimeter per second, or you can rewrite as 1 meter per second. All right. So we are using the tape, the ticker tape. By pulling it over a ticker timer, we are able to identify the linear motion of the trolley. So we were using a trolley, right? So you want to know what was the speed of the trolley? What is the acceleration of the trolley? What is the velocity of the trolley? So by using a tape, we are able to do that. So we just need to measure the length of the number of dots or intervals that we are looking at. And based on the pattern here, we are able to find the velocity of the system. All right, we're able to find the velocity of the system. If you look at the second part of the sticker tape, there are 5 cutouts now. Earlier, we saw only 1 cutout out of 5 cutouts, but we're still going to calculate the velocity. So what we do here, formula is still the same, displacement over time for velocity. So total displacement, each paper is 8 cm, you got 5 paper, and then what is the total time? Each paper got 5 interval, 1, 2, 3, 4, 5, 5 interval, 5 dots. Each one we learn already 0.02 seconds because it's still maintaining the frequency of 50 hertz. So the time between 2 dots will be still 0.02 seconds, so times 5, and there are 5 papers, so times 5, we end up getting 40 cm over 0.5 seconds, and the answer is actually 80 centimeter per second or zero point 0.8 meter per second. So ticker tape is very useful. We can use ticker tape to identify speed or velocity or acceleration of a movement. That's why you use ticker tape. The ticker tape also can be used to calculate or measure acceleration of any motion or movement like a trolley. So let's say the trolley is attached here. The trolley is actually dilekatkan attached here. All right. The trolley is here. Okay, now. So the trolley is moving in this direction. Why? Because they say this is an acceleration. In an acceleration, the velocity must increase over the time. So how do we know velocity is increasing? See, for the first 10 dots, short, then getting longer, 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 and longer. So final velocity must be higher than the initial velocity if you want to calculate acceleration. So how do we know direction of movement? The shorter path take as initial velocity and the longer path take as the final velocity, because that's how we know it is an acceleration. So the formula for acceleration is A equal to V minus U per T. So when we look at it here, what happened here, carefully see here, what is the initial velocity? The first part, which is x1, 4 centimeter, and since it's a 50 dots, each part will have 10 dots. This diagram got some error here, only showing 9 dots, but never just assume 10 dots. So 10 times 0.02 second. All right. So 4 over 0.2, you get 20 cm per second. So the initial velocity here is 20 cm per second. Important note here. Any journey, when we start a journey, we should know that this journey, initially, it will start at 0 velocity. So the first dot actually don't have any point of velocity. The initial velocity of 20 was only achieved at the end of the initial velocity distance. So initial velocity was 4 cm. After the paper was pulled 4 cm, then only the initial velocity of 20 was achieved. Clear? The final velocity is the last part of the paper, the ticker tape, which is x2, 20 cm. And inside there got 10 dots. So we got 0.02 times 10, 0.2. So we get 20 over 0.2 seconds. We got 100 cm per second. This is the final velocity. Okay, here's the final velocity. All right, this is the final velocity, 100 centimeter per second. Next, what is happening? So initial velocity, final velocity. We want to count the acceleration because the ticker tape can be used to find acceleration. So what is acceleration? A equals to V minus T. So V, we know the 100. U, we know the 20. The time between V and U, as I said earlier, the final velocity which we found 100 cm per second was achieved at the last one, here. All right. The initial velocity, which was 20, was achieved at the end of the initial velocity. Therefore, the time that we're going to take for acceleration must be from here to here, after the initial velocity. So always, if you are using ticker tape, if you have, let's say, for example, in a ticker tape, let's say you have 1, 2, 3, and 4 parts. This is the initial velocity and the final velocity. So the time you only take last 3. So if you've got 4 parts, take 3. If you've got 5 parts here, only take 4. 1, 2, 3, 4. So 4 times, as we know just now, that each of these got 10 intervals or 10 dots, and since the frequency is 50 hertz, we know very well already. In between 2 dots, 0.2 seconds, so we get 0.2 seconds. So what happened? Each 10 intervals is 0.2 seconds. So we got 4 intervals, 1, 2, 3, 4. So 4 times 0.2, we get 0.8. So 100 minus 20, 80. 80 over 0.8, we got 100. So this whole paper shows an acceleration of berapa? Acceleration of berapa, guys? 1 meter per second square or 100 cm per second square. All right. This is how we identify acceleration of a ticker tape. All right. So we identify direction. We identify the longest part, whichever on the left or right is the final velocity. The shortest one is the initial velocity. Then we know it is only initial velocity starts first. That's why I know this paper on the left is the initial velocity. So it is moving towards the left. Okay, guys, if you see here, again, we're going to calculate acceleration, but this time the long paper was cut to 6 pieces. They cut the paper to 6 pieces, like this, okay, the long ticker tape. The first part, second part, third part, fourth, fifth, and the last one, you know. So the length is increasing definitely for the same time period. Each paper got 10 intervals or 10 dots, so each paper is 0.2 seconds. Each paper is 0.2 seconds, but the length is increasing, so sure this is acceleration. As we know, acceleration must be final minus initial velocity over the time given. Okay, so what was the initial velocity? It's here. Initial velocity 0.5 cm over this part got 10, so 10 times 0.02, as we said, no, 0.2 second. So 0.5 cm or 0.2, we get initial velocity as 2.5 cm per second, the first part. And the last part, the final velocity, the length is 4 cm over, so now we know that each paper is 0.2 second, so it's 20 cm per second. So what is the time taken between the final and the initial? As I told earlier, if there are 6 cutouts like this, only take 5. So the first one you exclude, don't include. So if let's say a graph got only 3 cutouts, then only take 2. The first one exclude lah. So here got 6, I only take 5. So now 5 cutouts, each cutout 0.2 second. So it's actually 1 second. So 20 minus 2.5, all right, over 1, we get 17.5 cm squared. This is the acceleration for this part of the paper. All right, this is the acceleration for this part of the paper.